All right. So the stuff that we look at today, we're still ultimately trying to do the same thing. We're still trying to factor the trinomial. However, they don't look like what we saw last week. Last week we factored by the greatest common factor. What did all parts share in common? Pulled that out, put the remaining back in the parentheses. Today, you could expect to see something maybe that looks like this. Okay. That is what is called a factorable trinomial. So in your packet on page, I don't know what page is that in your packet, page 5. Okay. It does not have a greatest common factor. There is not something that all three of them share in common. So can't pull anything out. Last week we also learned that we could group things into sets of 2 and just look at 2 of them for what they had in common. Again, though, that's a problem because, well, there's not 4 items here, so we can't group them into sets of 2. We need a different strategy. Okay, so today, that's what we're looking at. Anything of the form x squared plus bx plus c. Okay, so x squared plus bx plus c. So b simply is a coefficient, c is a constant. Anything that looks like that. All right? What's up, Mia? If it's done. Yep. Thank you. All right. So we will be looking at things today where, what if b and c are both positive numbers? So like in that example, x squared plus 7x plus 12. 7 was positive, 12 was positive, okay? What if the middle value is negative, but the last value is positive? What if the last value is negative? Okay, so we'll kind of get into how all that can be played. And then the last thing we're going to do is be solving. So really, this should say something that looks like that, where it's an equation that's set equal to 0. We learned last week that if it wasn't equal to 0, we would just simply add or subtract it over to the other side to make it equal to 0. All right, so our goals or our objectives are exactly that. How do I factor something that looks like this? How do I solve an equation that is set equal to 0? And if it's not, we add and make that happen. In order to be able to do that, we need to be able to answer these first 2 questions. Okay. So can you think of something, a pair of factors for 8, so something that multiplies to 8, but sums to 9 or adds to 9? Give me something multiplies to 8, adds to 9. Yep. Think of something that multiplies to 8 and adds to 9. 1 and 8. Okay. If you took those 2 numbers, they multiply together to give you 8. They add 1 plus 8 to give you 9. Okay. How about this one? Give me something that multiplies to 30 but adds to negative 17. Multiplies to 30, adds to negative 17. She was too good a second ago. Now she needs a calculator. Dylan, what do you think? Negative 15 and negative 2. Okay. Negative 15 times negative 2. 2 negatives give you that multiplication of a positive. But when you add them together, you get a negative 17. All right? Yes. Okay. Well, in number 3, this is something that we've already done, right? What method puts number 3 together? Foil. All right. First, outer, inner, last. You got an answer there? What do you got, Mia? X to the second.
Plus 5x.
Yep.
Plus 6.
Very good. So your outers and your inners, 2x and 3x. 2 plus 3 gives you that 5x. But then last, 2 times 3 gives you 6. So x squared plus 5x plus 6. You got the last one? What do you got? R to the second. And then what? You're missing something. You don't have your inners and outers. I'll take your R to the second, and I'll take your negative 45, but there's a middle term in there. So minus 4R. So R to the second minus 4r minus 45. Okay. Now, if you look at these two, number 3 and number 4, they are exactly of the form that we're looking at today. They are x squared plus bx plus c. And maybe this b value is a positive like it is with the 5, or maybe it's a negative like it is with the 4. And then the end number, the c value, maybe it's positive, maybe it's negative. It really doesn't matter. All right. Hopefully this one example here is enough for us to understand what's going on. We today are going to be looking at it over here on this side of things. Okay. But the factored answer, which is what we're trying to get to for this problem, looks like this. So can you see how these two items are related to each other? Look at the factored pieces. Okay, these two over here on the left. We're going to be over here on the right today, looking at this x squared plus 7x plus 10. And we're going to ask ourselves one question, and it's exactly like the first two that I showed you. Can you tell me something that you know what it is? Well, what multiplies to 10 but adds to 7? Can you find me something that multiplies to this 10 right here, okay, but adds to this 7? And Alexis said that was going to be a 5 and a 2. If you think about it over here from the right-hand side, if I was to FOIL this together, there's my x squared. My outers and my inners are 5x and 2x, or 5 plus 2. That's where I get my 7. And then my last is 2 times 5. It's where I get my 10. Okay? So just like right here, when I asked you, can you give me something that multiplies to 8 and adds to 9? Right? Come down here and look at this one. Can you give me something that multiplies to 6 but adds to 5? Something that multiplies to 6 but adds to 5. Can you do it, Sam? That doesn't. It multiplies to 6, but it doesn't add to 5. That adds to 7. 6 and 1. Jacob? 3 and 2. That's why if we take this away, this said positive 2 and positive 3. Because those two numbers multiplied to 6, but they added to 5. What about this last one? Can you give me something that multiplies to negative 45 but adds to negative 4? You could look back in your paper because you should have FOILed this a second ago if you did. What is it? Negative 9 and positive 5, which is why these two factors were r minus 9 and r plus 5. Okay. So in your notebooks, or in your review packet, on this page that says factorable trinomial, I want you to write this down underneath there. Well, maybe at the top because you have space at the very top. We're going to put this question down. We're going to ask ourselves this anytime we see something of the form x squared plus bx plus c. We're going to ask ourselves, what multiplies to this c value? Okay, whatever's on the end. What multiplies to c that adds to b? Okay. We can't ask ourselves, what do they share in common? Because nothing we look at today is going to share anything in common. Right? I mean, look at this one here, x squared plus 15x plus 36. They don't share anything in common. We have to have a different question. And when they fit the form of x squared plus bx plus c, what we call a factorable trinomial, then we have to be able to ask this question. Can you find me something that multiplies to 36 and adds to 15? Find yourself something that multiplies to 36. And the hardest part's going to be, you guys are going to have like a common thing that you think of for me, for 36, 6 times 6. But that doesn't add to 15, so it's not the right set. You know what it is? 2 and 13. Well, 13 times 2 is 26. You're close. 12 and 3. Okay. Now, in order to write this, though, what's it going to look like when I write it? If the two numbers are 12 and 3, very good. One set of parentheses is going to say x plus 12. The other set of parentheses is going to say x plus 3. Does it matter which one of those sets of parentheses I write first? Why not? Well, true, they are positive, but when I say which set, like if the x plus 3 was over here on the left-hand side instead of on the right-hand side, does that matter? So you're saying it does or it does not matter? It does not. Good, because multiplication, the order doesn't matter. Very good. Okay. All right. What about these two? On the left-hand side, what's the question you're going to ask yourself? On this one over here, on the left. What is the question you're going to ask yourself? Good. Can you find me something that multiplies to 24 and adds to 10? Trent, you think of something multiplies to 24 and adds to 10? Okay. It's all right. Jayla? 6 and 4. Good. That multiplies to 24. 6 plus 4 gets you to 10. So what am I going to write for my factored answer? Good. So in one set of parentheses, x plus 4, and the other set, x plus 6, or vice versa. Okay. What about the other one? Holly, what's the question you're asking in the one on the right? Good. Multiplies to 12 and adds to 7, right? 3 and 4. So what are you writing? There you go. Okay. Are these difficult? No, as long as you can remember what question to ask yourself. If you don't remember the question, though, you're going to struggle because there's no greatest common factor. So you're not pulling anything out that they share in common. Okay. You have to be able to think in a little bit different of a manner. Excuse me? 6 and 2 adds to what? Adds to 8. All right. And why are 3 and 4 the right factors? Because if you think about foiling, your outers and your inners, we add those together, right? And so that's where we get that middle value. So it's important that we're able to find that. Now, what if they're not both positive? What if it looks like this? Not really. What are you asking yourself here, Jacob? What are you asking? Come on. Good. They are both going to be negative, right? Because you have to multiply to a positive 15, but you got to add to a negative 8. So the only way you can multiply to a positive and add to a negative is with two negatives. What's up? So you're asking yourself what multiplies to a positive 15 but adds to a negative 8, and you said those numbers are negative 3 and negative 5. How do I write that one? There you go. X minus 3 and x minus 5. All right? There's going to be two of them here. Pick one. See if you can give me an answer to one of those. Now here, though, C is a negative. How do you multiply to a negative number? How do you multiply to a negative? Okay, so a positive and a negative. Okay, hold on. I mean, some of us got to open our eyes for a minute, you know what I'm saying? So just hold on. So on the left, I'm trying to multiply to negative 18 and add to negative 3. And on the right, I'm trying to multiply to negative 20, but add to negative 8. And if it's possible, you're only finding one. There's only one possibility that's going to make this work. You got one? Which one you got?
The first one.
Okay, the one on the left. What do you think?
-6 and 3.
Negative 6 and positive 3.
Yeah.
So what are my two factors going to look like?
Doesn't really matter which position it is.
It doesn't matter which set you write first, but your signs are going to matter.
Okay. X -6.
Okay.
And X +3.
Good. So x minus 6 and x plus 3. So it doesn't matter whether you put the x plus 3 first or second, but it does matter which one gets the negative. Okay. In this case, because I was going to add to a negative 3, I was going to have more negatives than positives. So even though negative 3 and positive 6 still get you into negative 18, it doesn't work for the middle. So you had to make sure the negative was attached to the 6. Jaylee, got the other one? What do you got? Negative what? Negative 2 and positive 10. You agree? Is that what you said? Yeah? Gee, many Christmas. Anybody else? What's that? I'm sorry? Take yours off. Why? Oh, good, good, good. So this one worked. The top one works for the negative 20, right? Because negative 2 times positive 10, that is negative 20, but very good. It adds to a positive 8, not to a negative 8. So unfortunately, it can't be the first one. Okay. Why can it not be the second one? It's 10, not 20. And if you add negative 5 and positive 2 together, what do you get? Try again. Negative 3. Okay, so it's not going to be this one. Is it the last one? Yeah, a negative 10 and a positive 2 still gives me that negative 20, but when I add those, I get negative 8. So that is the correct one. I think probably the hardest thing you're going to do here is when you hear a number and you're asked for factors, you're gonna immediately jump to one that like is the most common. So when I hear 20, my first thought is always 4 and 5. But I'm not getting to an 8 using a 4 and a 5 if I have to add those together. Not with one positive and one negative, or two positives or two negatives, or whatever it is. That's not going to happen. Okay. So we do need to be careful there. We'll go ahead and let this one go. We're going to jump over here because this is the last thing we're going to look at today. Obviously, anytime we're dealing with a quadratic, the goal is to solve it, to get a solution. So if my equation is equal to 0, that's good. If it's not, like number 3, I'm going to have to move that over to the other side. In this first one, can you find me something that multiplies to negative 21 but adds to negative 4? Multiplies to negative 21 but adds to negative 4. Maddie? So you're going to write what? Okay, now just like we did on Friday when we were working with the greatest common factor, if these two factors are equal to 0, then that must mean that either the first factor, x minus 7, is equal to 0, or the second factor, x plus 3, is equal to 0, or potentially both of them are equal to 0. So we can have up to two answers here. If I solve the first one, what answer do I get there? I get positive 7. Second one, negative 3. Okay. Now, in the bottom one, what's the first thing you have to do? You want to stand up so you stop sleeping? Because I mean, I guarantee you have no idea what's going on because you haven't spent 30 seconds awake. Okay. You got to do something first. Before you go trying to figure out what multiplies to one number and adds to a second,
You gotta move 24.
you got to move the 24. How do you move it?
Adding 24 on both sides.
Okay, so I'm going to add 24 to both sides. It's not a like term with anything that's there, but it does force this equation to being equal to 0. Now that changes your thought now, because now you're talking about multiplying to a positive 24, but adding to a negative 10. Multiplying to a positive 24. So think about the things that'll get you to 24 and adding to a negative 10. And I would even tell you right now that you know if you're multiplying to a positive, but you're adding to a negative, that both of them are going to have to look like that. They're both going to have to be negatives. It's the only way you can make that happen. You know what it is? Okay, so it's not a 12 and a 2 anymore, right? Now it's a negative 4 and a negative 6. Those are the two numbers that make that work. So again, if these are the two factors, then each of them needs to be set equal to 0. Okay. And obviously, in this form, it's pretty easy to see what your answers are going to be, right? So here it's a positive 4. That's what makes that one equal to 0. And a positive 6. That's what makes that one equal to 0. Okay? Yes, ma'am.
This could be way off.
Oh, it's all right.
Do it later.
Yeah.
But can you scroll back up to
Yeah. Like to this problem or the previous one?
that is fine. But can you see that X to the second?
Yep.
What if it was to the third? Like I might like when you put it in the toilet, you'd have to distribute. What would you do there?
Yeah. So now you're talking a new method. We're not going there, not this year. That'd be like algebra 2. How do I handle something that's raised to the third power, especially if they don't share anything in common where I can't reduce out a greatest common factor? And we're going to see then in the next unit we get into how we can graphically look at this to see those results. And that would really be a method that we could try there. That's a good question, though. All right. So I'll just try these two and then we're done. Okay. See if you can't come up with what the answers would be. So in the first one, it's already set equal to 0. In the second one, obviously you have to move the 36, but we're looking for two solutions. Hopefully, maybe. So remember, what multiplies to C that adds to B? And obviously, I did ask you to turn to page 5 in that packet. So there are just a couple questions there. If you have not already, you would want to complete in your review packet as well, so that you're just starting to build kind of a library of what these different factoring options could look like. In that first one, you're going to ask yourself, can I find something that multiplies to a positive 2 but adds to a negative 3? Can you think of something? Multiplies to a positive 2. Not a whole lot of options there, right? Trent, you got an answer or a question?
Well, I didn't know if you were like trying.
Yeah, if you're ready. You got the first one? Okay. Well, first of all, what do you think multiplies to a positive 2 and adds to a negative 3?
Negative 3.
That multiplies to 3. Holly? Negative 2 and negative 1. That multiplies to a positive 2. It adds to a negative 3. So n minus 2, n minus 1. Okay. Neither one of those are my answers. Those are my factored forms of the equation. So what's the answer that satisfies the first factor? It is 2, right? That's what makes that one equal to 0. And what makes this one equal to 0, obviously, then would be a 1. Okay. Now, in the last one, you got to move the 36. How do you move it? Sam? By adding it. Good. If you add it to the other side, what's your new equation say? Yep. Good. So I'm looking for two things that multiply to 40 and add to 12. Multiplies to 40 and adds to 12. Mia?
I got negative 8 and negative 4.
What's 8 times 4?
Positive 12.
What things get you to 40? Give me something that multiplies to 40.
Oh, I did something wrong.
Yeah, you put together those. Yeah, I got you. I know. You just combined those two and had negative 32, didn't you?
Yeah.
Yeah.
I didn't think about it.
That's okay. Give me something that gets you to 40. 10 and 4. If I multiply 4 and 10, I get 40. If I add 4 and 10, I get 14. So is it the right set? It's not. So give me something else that gets me to 40 other than 10 and 4. You got another one? What? 8 and 5. Multiplies to 40, adds to 13. Closer. Okay. Give me something else. Multiplies to 40. What you got? That's fine. What is it? Oh. Well, I mean, 2 and 20 will get you to 40, right? Okay. It's not a whole number, is it? I mean, your only other option, we had 4 and 10, we had 8 and 5, we have 2 and 20, there's one more. What's the last one? 1 and 40. That doesn't get you there either. There is not a whole number that makes this work. Okay? Now, is it a decimal? Maybe. Okay? Listen, if it's a decimal, this isn't the method to figure it out. I'm going to tell you that right now. Okay? At this point, if we are unable to find something that multiplies to the C value and adds to the B value, not because we can't think about it or we don't want to think about it. If we listed out all the factors and none of them work, then for now, what we're going to say is that it can't be factored. That we can't find something that makes that work. Okay? That does not mean that your homework tonight is going to have 12 CNFs written down it. Oh, sorry. Couldn't find anything that multiplied to 12 and added to 7. I mean, I tried them all. They just didn't exist. Okay? That's not the case. Few and far between. It may actually happen. Two possibilities. One, it really truly doesn't exist. There is not an answer. There's nothing that makes this work. Or number two, they're not whole numbers. Okay? Either way, we'll talk about that further. How do I get to that point? How do I actually figure that out? If I can't find it by factoring. Okay? Tonight, you are looking at not a lot. This 12 through 29, there are actually 2 columns in the book. Typically, there's 3. There's only 2. So you can pick first column or second column. I don't care. Your choice. And then those 4 problems, 41 and 42, and then 50 and 52. This 12 through 29, the first part of it, you're just factoring. So just 2 sets of parentheses. In the second part, then you will actually find your factors and then find your solutions. So if they're not equal to 0, you'll make them equal to 0. If they're already equal to 0, then you can just go from there. Okay? Any questions on that? Okay.